we have talked about definite integral, fundamental theorem of calculus. So basically we set up a definite integral. For example, in this problem, I have a definite integral from 0 to 60, and then we have an integrand 3 minus 4 e to the negative 2t dt that is equals to a number, right? After you evaluate the integral, what does that mean? You might say, okay, so the answer is the area under the curve. The area under the curve from 0 to 60. But my next question is, what is that area means in terms of this problem? So in an application problem, area is just a result. But what does that mean when you apply that to an application? Tell me what that means. So let's read the problem first. The rate in liter per minute that the water pumps out of a tank is represented by this function. So this is you can call this a velocity, a rate of change, whatever you like to call. And then the t is the time in minutes since the pumping started. And then you have to find the total number of liters of water pumped out of the tank after 1 hour, which is 60 minutes. All right, so let's take a look at the graph. So I just graphed the function for you. So this is an exponential function, 0 to 60. You have this area. So let's cut a piece of the area and then interpret what that means. So let's use red. So let's use a left sum. Doesn't matter what method you use. So let's use the left sum. So we have a point right here, and then we go a few units to the right, and then we sketch our rectangle, right? And then the base of the rectangle is delta x. Now, I want you to tell me what is this piece of area mean. So first of all, what is delta x mean? So the delta x is time in second, right? And then what about the height? The height is vt, so it is the vt. That is the rate. So that is the rate, velocity, whatever you like to call. So that is the rate. So let's say rate. What is the unit? The unit is in a liter per minute. And then the total number of liters, so which is the total number of liters, so that is equals to rate, and then you multiply the time, right? So the rate is in liters per minute, so that is in a liter per minute. And then the time is in second, but we can easily convert that to a minute. So what is the total? The total is in liter, right? So whatever area that is the number of liters of water pumped out of the tank. So liters of water pumped out of the tank. All right, then we solve the problem. So the problem is 60 minutes, right? Okay, then we do this integral. So we have an integral. I should match the color. So we have an integral from 0 to 60. So we have a 3 minus 4 e to the negative 2t dt. And then the integral of 3 is equals to 3t. And then for the 4, so the integral of e to the anything is e to the anything, right? So this is e to the negative 2t. But do you think that this is right from 0 to 60? Can you tell me, is this right or wrong? 4 times e to the negative 2t. What do you get when you take the derivative? The 3t you can easily get back to 3. But when you take the derivative of e to the negative 2t, that generates a negative 2 due to the chain rule. Again, when you take the derivative of e to the 2t, that generates a negative 2 due to chain rule. So how do you get rid of that negative 2? We will have to do a 1 over negative 2 over there. So now, when you take the derivative, the 1 over negative 2, get rid of the negative 2. Simple, right? Okay, and then you proceed to clean that up. So you have a 3t, and then plus 4 divided by 2, which is just a 2, right? So which is just a 2. And then e to the negative 2t, and then t goes from 0 to 60. And then you do the plug-in. So you have a 3 times 60, and then plus 2e to the negative 2 times 60. So this is the upper limit. and then minus the lower limit 3 times 0, and then plus 2 e to the 0. And then what is that equals to? So this is equals to 180 plus e to the negative 120, and then this becomes a 0, but e to the 0 is a 1, so you will have to minus 2. So this is equals to 178 liters. What is this? This is 178 liters of water pumped out of the tank in 1 hour. Pump out of the tank in 1 hour. And then let's ask another question. So let's say we have 500 liters initially. How many liters do we have after 1 hour? So let's say we have a 500 liters initially. After 1 hour, how many liters do we have left over in the tank? So you take 500 minus 178, so that is equals to 322 liters in the tank. After 1 hour. Alright, so that is the end of this video. If you like it, give me a thumbs up, a subscribe. I truly appreciate your help, and I will see you all in the next video. Signing out.